The part about containers in C++ that you really want to understand the most is which container do I want to use. And we're going to talk about that in this video in just the broadest terms, because you need to familiarize yourself with these, and you'll have a favorite that you tend to use, and it's probably going to be the vector. But understand, of the 6 containers in the C++ standard template library, there's a lot of possibilities here for dealing with the data that you normally deal with, because keep in mind, what we're normally writing with programs is really nothing more than memory collection, management, and reporting, right? And so the 6 containers, I've already talked about them in the video entitled C++ containers, but they're the vector, the dec, looks like DQ, list, map, set, and bit set. So let's look at each one of these and talk about generally what they do, and this will help you understand why you need to familiarize yourself with these, play with them, and learn how to use them. Now the vector, which is what we're going to do examples on in some separate videos, is simply an array that will grow in size automatically. Now this is really cool, because the challenge with arrays has always been, okay, how do we resize them? You know, we'd redimension them, we'd do all kind of stuff, and so there's a lot of overhead, a lot of things involved. And so each one of these containers is built and designed with certain characteristics in mind so that they're more efficient at different things. So a vector is going to grow in size automatically. Now new elements are added very efficiently only to the end. Now you can add a new element to the middle, but you involve a fair amount of overhead, and it's not what the vector is really built for. But if you want to throw things into an array really quickly, use a vector. And I'm going to show you some programmatic things that you can do with vector that's really neat and really cool. We'll look at that in a separate video. Now the dec, notice it's dec T. This is very similar to a vector, except with this one you can also add elements to the beginning. Now what we're really getting into here is when we need to manage lists. This could be customer call tickets, this could be all kind of things, but whether we need first in, first out, last in, first out, all those kinds of situations that you get into, it's going to determine, for example, what kind of memory container you would use here. Now let's move on to the list. And this is another popular one. Data can be added or removed from any position in the list. Now the data can also be reorganized, so think sorting. Anytime I'm going to collect a list of things and then sort it in some sort of order, the list container is the one I want to use. Now the map container, notice this is one of the ones that uses K. So this is going to use key values to help, and the data is going to be stored based on that key value. Okay, you know, color equal, name equal, that sort of thing. All right, now the value of each key must be unique. All right, so color equal red, color equal blue, color equal green. Makes sense? 2 color equal red is going to cause a problem here. All right, but with a map, that's what we can keep up with. Now a set, notice set T. This is a map in which each object is its own key. Now each object in this one has to be unique. Now this is more or less a vector, but everything has to be unique. In a vector, I can have 10 elements and 4 of them can be identical. Okay, so I can have 4 identical numbers in there. In a set, can't do that. Each individual object must be unique, and objects can't be changed here. Okay, in a vector, I can set, you know, element number 3, if it's equal to 10, I can just set it equal to 12 and it'll make the change. In a set, I can't do that, and I have to delete that particular object and then go back and insert a new one. All right, and then bit set, this one's very efficient for all kinds of things, but with this stores a fixed number of bits in the container, in the bit set container, and of course each element only has 2 possible values, a 0 or a 1. Okay, now as you can see in this short video, these containers, 6 with some sub-containers under these. Okay, for map, you know, you can do a multi-map, there's all kind of little things. I won't go into that now, but there's a lot of functionality here that you will need from time to time. And since you're writing in C++, you've chosen the language. One of the reasons is because you can manage the memory completely, you can really wring performance out of a C++ program, make it run really fast, very efficiently, and knowing these containers and knowing which one to choose can really help in that department. Okay, so now let's in some separate videos go take a look at using, for example, the vector container.